Okay, so the next problem we are solving in Leet code is to rotate an array by k steps. Okay, and also we are supposed to rotate it by right. Okay, we are given the list of numbers, and also we are told how many times we need to rotate it. Okay, so here they have given the explanation that it was initially like this. After rotating it by one, I mean the end will go to the beginning, and it keeps on repeating. Right, they are rotating it by, they rotated it by 3 times. Okay, this is the output. So coming to the approach, right, what we can do here is, so before actually jumping onto this, let's try to understand one case here. So let's say that k is equal to 3. Okay, so let's say that if k becomes greater than n, so we might be rotating again and again, correct? So let's say that here we have here we have a 4 elements, correct? So if the k is equal to 4, if we are rotate it by 4 times, we'll land into the same, correct? 99 will go here, 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 and it will come back here in the same position, correct? So we need to understand that. Okay, let's say that k is equal to 5 this time. Okay, so after shifting it for 4 times, we land into the same thing again. And when is equal to k is equal to 5, this 99 will go to the beginning, right? So we are unnecessarily rotating the arrays again and again. So you need to avoid that. Okay, like this will be the condition when k is greater than n, correct? So that will handle that case here, such that we'll be taking the remainder of it. Okay, k divided by length of the element, 2 divided by 4, like how many times we'll get the updated k. Okay, k is equal to 2, so we'll have to rotate it by only 2 times, right? And also let's say that if k is equal to 4, we'll get k is equal to 0, so we won't rotate it at all. Like, I mean, we'll leave as it is. Okay, that is the case here. We'll need to understand that part. And what is the approach, or what is the problem, how I am solving this problem is, so one thing we can observe here is, see, like, I mean, 1 2 3 4 5 6 7, k is equal to 3, right? When is k is equal to 3, it is nothing but last three elements will go to the beginning. Okay, that's what it actually looks like, correct? K is equal to 2, 399 will go to the beginning. Okay, so what I am doing here is, I'm just using it, storing this part somewhere. Okay, like k is equal to 3, whatever it is, right? I'm slicing it. It does involve some time complexity, we'll come to that. Okay, k is equal to 3, we'll store this somewhere. Okay, we are storing it, this will be the new beginning. Okay, and now what we'll do is, after the k is equal to 3 is stored, right, we can start shifting this number to the end. Like, we'll shift 4 to the end, 3 to the before that, 2 to the before that, 1 to the that. Okay, that part is done. Once that part is done, similarly this part is done now. Okay, like, I mean, we stored this part and we started shifting it, so we shifted it. And once that is done, the arrays whichever we stored, right, 5 6 7, that will be inserted in this part. Okay, this was it. And also we are supposed to do in place, right? So that was the solution actually. And yeah, like, I mean, coming to the time complexity, it will have around O of n only. Okay, but it involves like time complexity, so space complexity of O of k, because we are slicing an element, right? Slicing an list of length k, right? So it will have a space complexity. So now let's see that how we can reduce this space complexity also, correct? So coming back here, right, so it involves actually the three steps. Okay, so what are those steps is, the first step is to reverse an entire array. Okay, whatever the array we got, we'll have to reverse it. We'll come to that why we are doing it. Okay, and then we'll have to reverse k minus one element, right? Whatever the element that will be there after reversing, right, we'll have to reverse this. And rest we'll have to reverse this. Okay, and why are we doing this? Okay, like, as we know that 5 6 7, like, I mean, whatever, if k is equal to 3, right, this last three element will come to the beginning. Okay, so previously what we have done, we have made a copy of this 5 6 7. Instead of that, what we can do is, we can move this, like, I mean, if we revert it, right, if we reverse it, what we will get, okay, let's check it here, right? If we just reverse it, all those three elements will come to the beginning. I don't have to store it anywhere, like, I mean, it's a separate list. I just reversed it, so we got it. Okay, we got the 5 6 7. Okay, and here it is 5 6 7. After rotating, we got this. Now what we'll have to do is, we'll have to reverse it separately. Now 5 6, this will be separate thing, 5 6 7, and this will be separate thing. So at the end, we'll get a final result after a rotation. So that's how this is working. So yeah, like, I mean, why did we reverse? We reversed it because we know that the last portion, whatever the k elements, that needs to go to the beginning, so we reversed it in the beginning. And whatever, and also that's not in a correct order, right? 7 6 5, we need to um like, I mean, it should be in the same order, right? So we'll be reversing this part, and also this part, so we'll get a final answer. Yeah, that's it. Thank you.